Alright, here's another example of a Hess law problem. Now the first thing we want to do is, we know that this is the reaction we want to get at the end, so we need to make sure that everything is going to be on the correct side. So you can see that C3H4 only appears once in any of these equations, so I'm pretty safe in saying that it's already on the correct side, that I don't have to flip reaction 2. The hydrogen, looking over here again, H2 only appears in one equation, it's this one here, so I know that it's already on the correct side and I don't have to flip that one. The C3H8 though, you see, is on the reactant side. It needs to be on the product side, so I would need to flip this reaction in order to get this one right. So I know I have to flip reaction 3. The other thing I need to do is check my coefficients. I see I've got a 1 in front of C3H4, I've got 1 here, I've got a 2 in front of the H2, and I've got a 1 in front of the C3H8. So you can see that the only thing I need to do now is just flip equation 3. Now, what I'll do is I will rewrite these other reactions, and again I'm going to ignore the states here because there's nothing that's in more than one state. And just as a general rule, I think it's probably a good idea to try and keep the arrows aligned so you can make sure that you don't mix up what side things are on. And I'll put the delta H's over here as well. This can be kilojoules per mole. And that's going to be negative 571.7. And that's going to be negative 1941. And this one down here we're going to have to flip, so that'll be 4H2O plus 3CO2 gives C3H8 plus 5O2. Now because I flipped that one, I have to flip the sign. It's going to be positive 2220 here. Now I'm going to add all these together and hopefully I'm going to end up with what I want. And you can see I've got the two H2s over here, that's okay. I've got C3H4, that's okay. Now what you'll notice here is I've got oxygen, there's 1 there, I've got 4 here, 1 plus 4 is 5, and I've got 5 over this side, so that's going to cancel as well. Now over here I've got 2 waters, and 2 waters, that's a total of 4 waters on this side, and I've got 4 waters over here, so that's going to cancel as well. And you'll see I've got 3 CO2s here and 3 CO2s here, and all I'm left with on this side now is C3H8. So you can see that that's what we had wanted. Now if I go ahead and I add all these together, my answer is going to be negative 293 kilojoules per mole. And just looking at the significant figures here, we've got 1 decimal place, 0 decimal places, 0 decimal places, so the answer comes out to 0 decimal places, which is why I end up with this answer here.